namespace, there's no sandbox or whatsoever in between. Because, so what happens here is that the host actually loads a script from a foreign server.
So it's line means the ad server.
Right, it loads a script from the ad server. And so there's no difference for the browser. Right? Okay.
So are we assuming that the ad server here is malicious?
So the ad server here is malicious, obviously, right. Okay. So let's go back to print the presentation. Okay. So we've seen what can happen in your browser. What could you do to prevent these malicious attacks, right? One solution would be to escape all untrusted input. So for example, if someone inserts a script tag, you would change the script tag and insert greater and smaller signs instead of the tag angles. But this is not always what you want. Sometimes users are supposed to have scripts in the JavaScript, right? So when you load an app, the advertiser usually installs the advertisement with JavaScript. So you need to allow them to do something. Cannot always exclude everything. So another idea people had was rewriting techniques. For example, Facebook JavaScript is a dialect that does rewriting. But also the Yahoo AdSave and Google Caja do similar ideas. They rewrite the JavaScript that you are loading into your page. However, this is prone to obfuscation because first, browser parsers are not the same in all browsers. So some browsers might accept some JavaScript that others don't. And browsers are very lenient. I have examples for that coming up in a few minutes. And because of this filtering, there has been a lot of exploits already. So for MySpace, a very popular thing in the beginning was adding someone called Sammy. But this was not because Sammy was really popular, but because it was a worm. And I will show the code in a minute for that. For Yahoo Mail, there was a virus called Yammer, and here the filter actually introduced a malicious script. So what happened here was that you had a target tag, but a target tag is not allowed in Yahoo Mail. So it was filtered out, and because of that, the unload tag actually became active for the browser. So filtering might be a solution sometimes, but it can also be a problem. And for Facebook JavaScript, there has been people around that found several problematic issues too. And so there's more to come. It's not guaranteed that filtering will solve all these problems. So let's have a look at the semi-worm. How did that work? So MySpace blocks most tags. In particular, it blocks script tags, JavaScript. But some browsers accept JavaScript even in a style definition. So here the background style was defined as some JavaScript. So this did not work in all the browsers, but if you want to spread a worm, it's enough if enough people have such a browser, right? But since we can see that the single and double quotes were already used here, they could not use a different, more layers of quotes. So they had to find some possibility to use more quotes, and one thing they could do was to define an expression in HTML, like the one here. The expression is alert ha, and then the JavaScript can access the HTML, and so now they have a third layer of quotes, right? But then again, MySpace stripped out a lot of keywords that you would use for a worm. For example, the word JavaScript was filtered out. But browsers are, as I said, very lenient. So, for example, if you write Java, new line, script, most browsers will parse this as the keyword JavaScript, which is not what you would expect, but this happens. And the MySpace developers did not expect that either, so it was not filtered. Other document tags that were filtered was, for example, inner HTML, which is used to access the HTML source of a document. And here they used a different trick. They split up the word inner HTML into two strings, and then MySpace was no longer able to filter it. As you can see here, they were using ini plus r HTML. This is not filtered anymore. So static filtering is really not very powerful, right? The same idea was used for a function that they wanted to use for AJAX calls. And so now they can set the document location with JavaScript that they need for a certain domain. They can do AJAX calls to have post and get calls. And finally, with these techniques, they were able to add the user Sammy as a friend, because this allows everything you need to do for a CSRF attack. Okay. So besides what is out there for your everyday life, what does science offer as a remedy? Most solutions that I have found in literature are actually based on filtering as well. So they have the same problems. We have seen that using a parser's browser introduces dependence on that browser and also on a certain version maybe. If you use an independent parser, you will miss something because you will never have the same parsing. And there's one more issue here. In JavaScript, you can create another script at runtime. You can use something like document write, and with document write, you can write another script into your document at runtime in your browser. And static filtering techniques have a hard time with that. So what would be good design principles for security? What one would like to have is complete interposition. All the scripts that are run in my browsers have to be protected by the security mechanism. So even if I have scripts that are created by scripts, they should be monitored. That should be clear. But one would also want to have tamper-proofness. So user-created scripts must not be able to circumvent the security mechanism or tamper with it in unintended ways. So for example, if you define the security mechanisms in JavaScript, then the user script should not be able to change that policy. Which makes sense, right? And if you have those two design principles, then you have soundness for your approach. But there's more. Besides that, what you would want to have is transparency. So if your web page already adhered to all your security policies, then its behavior should not change. Only if something that you did not want to have according to your security policy, then the behavior should change, right? And the last thing is flexibility, which means the separation of the security mechanisms and the security policies. So if you change the security policies, you should not have to change the security mechanism. So now I will present some papers and works that have been proposed in the past. One is called Browser Shield. And Browser Shield rewrites the pages along with all the scripts that are included into safe counterparts. It inserts runtime checks even if you have dynamically created scripts. And this was proposed to prevent known vulnerabilities in Internet Explorer, because people, especially at universities and companies, they usually do not patch all the browsers immediately, but they first have to check that no side effects will happen when they do the patching. So it sometimes can take weeks or months until they will actually apply the patch. And to close the gap between the release of the patch and the installation at a client, they were proposing to have a security policy that prevents the exploit of that vulnerability that we were closing with such JavaScript. However, this was only able to parse 70 out of 250 samples correctly, so we can see that creating a good parser for JavaScript is not very easy, right? So another approach that I have seen is called lightweight self-protecting JavaScript. They are using ideas from aspect-oriented programming, and this circumvents parser mismatches because you're interposing some functions of your browser in JavaScript. So what they do is they wrap some native functions and only execute the original if some policy is abided. And here they have to make sure that only the wrapping function will reference to the original function, otherwise you could come back to the original JavaScript function. However, it's not clear because you could use iframes, and these iframes might have access to the original function again. Or in some browsers, if you delete the function and it's a native function, the original function will be restored. So you can circumvent this policy, right? So let's show a quick example how this would work. For example, if you have window.eval, which allows dynamic code execution, you would want to define a safe version of that in the end calls the original function. However, there might be several aliases to the same function. For example, window.eval and window.parent.eval would point to the same function. And there may be more. Maybe some of them might be browser specific. So it's kind of hard to guarantee complete interposition here, right? And some native functions cannot be redefined. For example, in Internet Explorer, the alert function that shows a pop-up cannot be redefined. Another idea that was presented in literature is called detecting malicious JavaScript code in Mozilla. And they are directly introducing their monitor facility into the browser, and the output goes directly to disk. And so now you can check what has been written to disk and compare it to a high-level security policy. But since this is only possible after you check